So in this video, I wanted to talk about different types of chemical bonds. Remember I told you guys that sometimes you have atoms that do not have full valence electron shells. And so if the valence shell is not full, then that means that atom is going to want to interact with other atoms to help fill that shell, so they'll become stable and happy. So they'll do that by forming chemical bonds with other atoms, and there are many different types of chemical bonds that can be formed. We're just going to go over a few of them here. The first one that I have pulled up is an ionic bond. Ionic bonds are formed whenever one atom completely gives up an electron and the other atom takes the electron away. Okay, so you can see an example of this between sodium and chlorine. Sodium, as you can see here, has this one little electron hanging out in its valence shell. So it's going to very much want to give that electron away and get rid of it, because if it tosses that electron out, then the next shell down is completely full. It has 8 in it, and so the sodium would be stable at that point. Chlorine, on the other hand, you can see has 7 electrons in its outer shell, and so it only needs 1 in order to fill that shell and be stable. So sodium and chlorine will react together very readily. Sodium will give up its electron that it has extra, chlorine will take it away. And when that happens, what do we know is going to happen to these atoms? What will they become? They'll become ions, right? If you watched that last video, we talked about if an atom loses or gains electrons, it becomes an ion, right? It's a charged atom at that point. So when the sodium gives up an electron, it's going to become a positively charged ion. Remember, we said that is a cation. And when the chlorine gains an extra electron, it's going to gain a negative charge, so it's going to become a negatively charged ion, which we know is called an anion. And since these two ions have opposite charges, what do we know about opposites? They attract, right? So this positively charged ion and negatively charged ion, when they're together in a solution, they're going to be attracted to one another because they have opposite charges. We know opposites attract, right? And so in a solution, they're going to hang out with one another and form this ionic bond, okay? So it's a bond between two ions, essentially, where the positive and negative charge attracts each other and holds them together, all right? But there's no direct physical connection between them. It's just an attraction between those positive and negative charges, okay? So that's an ionic bond. Now, the next type of bond that we see pretty commonly is a covalent bond. Covalent bonds are different from ionic bonds because here in a covalent bond, the two atoms are going to be sharing electrons. They're not going to be giving up or taking electrons. They're going to actually be sharing them with one another. Okay, so you can see this top example between these two hydrogens. Each of those hydrogen atoms only has 1 electron in its valence shell. And how many electrons do we know we need in that first shell to fill it? Just 2, right? So if those hydrogen ions come together and they share those electrons with each other, then they can both have the 2 little electrons that they need in order to fill their valence shell. Okay. Same thing with oxygen there. If you look at oxygen, oxygen has 6 valence electrons. So we know that each one of these oxygen atoms needs 2 more electrons in order to fill its valence shell. Okay. So if each one of these oxygen atoms shares 2 of its electrons, then they can have the full 8 that they need in their valence shell. Okay. So this is called a double bond. Whenever you see 2 valence electron pairs being shared, this is a double bond. This one here is only 1 pair of electrons being shared. That's a single bond. Okay, so that's the difference between a single or a double bond. Now, that's the simple version of a covalent bond. We actually have different types of covalent bonds that we can see, and these are called polar covalent bonds and nonpolar covalent bonds. Okay, so in a nonpolar covalent bond, the electrons are shared equally between the atoms, right? So if you look at either one of these bonds here, these are both going to be nonpolar covalent bonds. They're going to be sharing those electrons equally. And the reason I know that is because these 2 atoms are identical to one another. They're the same size, the same strength, and so they're going to be sharing those electrons equally. So the way I like to illustrate a nonpolar covalent bond is, if you imagine, I have an identical twin and we're both trying to take something from each other, but we're both the same exact size and strength, then neither one of us is going to be able to pull that substance or pull those electrons away from the other, right? So those electrons are just going to hang out right in the middle of us, and we're going to share them equally. Okay, so that's a nonpolar covalent bond, when you share the electrons equally between the atoms. Now, the other type of covalent bond is a polar covalent bond. This is when electrons are shared unequally. And this is going to happen whenever you have atoms that are different sizes and strengths trying to share electrons with one another. So if you look at this water molecule in this picture here, you'll see that the oxygen that they have colored in red here, that oxygen atom is much, much bigger, right? It has a lot more electrons, and so it's a lot stronger, okay, the easy way to put it, than those two hydrogen atoms. Okay, so that oxygen is going to be much, much better at pulling those electrons towards itself. Now, they're still going to be sharing the electrons because they're still going to be holding on to them. Each one of those atoms will be. But the oxygen is a lot bigger, so it's going to be pulling the electrons more closely to itself versus the hydrogens. Okay, so you can see the electrons are going to be hanging out closer to the oxygen up here at the top. And what's that going to do to the charge of that oxygen? Well, if it has those electrons hanging out closer to it, it's going to make it more negatively charged, right? And then the hydrogen ions, inversely, are going to become positively charged. Okay, so it's going to give a charge, overall charge, or what we call electronegativity, to those atoms within that compound, right? So that's going to be different. They're sharing these electrons unequally at this point. They're not shared equally between the atoms. Okay, that's a polar covalent bond. All right, next type of bond I want to get into is a hydrogen bond. Now, hydrogen bonds are formed between hydrogen atoms and some other negatively charged atom. So if we go back to this water molecule that we were just looking at, remember, oxygens are going to be more negatively charged, that hydrogens are going to be more positively charged. So if you throw a bunch of water molecules together, then what happens? You have positively charged hydrogen atoms being attracted to negatively charged oxygen atoms, and that forms what we call a hydrogen bond between those two atoms, because they're opposite charges. It kind of attracts them to one another. Now, these hydrogen bonds are very, very weak bonds. They're not very strong at all, or individually. But when you put many, many of them together, like millions, like you would see in a glass of water or in a pond, then they can become fairly strong. And they can form things like water tension or surface tension of water, okay, which you can see in this picture here. So surface tension of water is formed by those hydrogen bonds holding those water molecules together. And that prevents very light things from breaking through those hydrogen bonds and getting down into the water. So like this little water bug can walk on top of the water thanks to those hydrogen bonds. Now, we obviously wouldn't be able to because we're so heavy that we would break through those hydrogen bonds and actually fall down into the water. Okay, but lighter objects like leaves and bugs can stay on top of the water due to that surface tension that, again, is formed by those hydrogen bonds. Okay. So hopefully this video helps you out in distinguishing the different types of chemical bonds, how those work, how those are formed between atoms. If you have any questions about this, please let me know.